Okay, now before I get started, what I'd like to do is demonstrate the performance with just one GPU on one machine. So I have the data set here. It's comprised of a total of 50 images, and we're going to run the tracker on it like we normally do. So I can go ahead and specify this, all these normal settings here. Oh, by the way, this is going to go away in version 2.7, or at least it won't be necessary to manually tweak this. You'll be able to click a button, or potentially you won't even have to use this dialog at all. So you can click auto threshold, and it'll choose an optimal threshold for you. Anyway, continuing with the example here, again, I'm just going to use some default settings for the tracker. In this case, the max object speed I'm going to look for is 3 arc seconds per minute. And so let's run this with the 4 threads. And again, I want to do it for just one machine. So I'm going to deallocate those remote nodes and just run it all on this one machine. So I'm going to click OK, and I'm going to click Begin. And what you'll notice is it's probably going to take about 3 minutes to process this data set on this one machine. Okay, so I'm not going to record for a whole 3 minutes of just progress bars. So let me go ahead and pause the recording. Okay, so it finished processing the data, and if I look at the file information here, you can notice that it took 103 seconds to run on one machine. So 2.5 times E13 vector pixels per hour. Anyway, so in this, just to give you some more information here, in this data set we have one asteroid that is authentic. It is a real asteroid. So if I were to animate the frames, you would see that. Anyhow, so there's one genuine asteroid, and then I also injected 100 other asteroids, all having the same motion, and so you can kind of see that here. Anyway, the point of this exercise is to validate that yes, they can see the genuine asteroid as well as all these synthetically injected ones, and it comes back with 907 detections for this particular detection threshold. Anyway, but the point to note is, again, 103 seconds to run it on just one node. So let's go ahead and close out of that. And let's try again. This time I'm going to run 4 worker nodes, and let me show you how that's going to work. So if I go over to Network, I can manage the worker nodes for this particular machine. So first off, let me just go ahead and start from scratch here. And the starting, let me just, again, from scratch. So port number, you give it a port number on which to connect, and you also choose what GPU you want to use. So again, this machine has 4 graphics processing units. So I'm going to just go ahead and add all 4 of them. So I'm going to add that one to list. I'm going to add that one, and the last one here. So I've now added all 4 GPUs, and I've attached them to this machine. And if I wanted to, which I do, I can also get the syntax for how to start these worker nodes from the command line. So I just created a very simple script that it's a batch file, really. So it invokes the Tycho process, and it specifies port numbers, node index, device index. Anyway, it's a really simple copy and paste from here to here on this file. And what that allows me to do is I can simply double click on the script, and then it launches all 4 of the worker nodes for me. So now when I go to the manage the cluster configuration and I click on ping, you'll notice that it is able to ping all of these worker nodes on the local host. And yes, I also have them running on a remote host as well. So let's go ahead and take a look and see what the performance is like. now that we have 4 worker nodes on this machine. So we'll go ahead and start the tracker. And again, as before, I'm just going to use some default settings. So with limiting it to 3 arc seconds per minute for the search range. So yeah, this time I'm going to choose all of these local worker nodes. So they have been allocated. I'm going to click OK and distribute the data set. And having done that, I'll click Begin. So we're going to see how long does it take to process this data set using 4 GPUs simultaneously. So you would expect, okay, rather than 103 seconds, it might take somewhere around 25, 27 seconds. So let's give it a moment and see here. Okay, so it's already finished, and if I look at the track file info, 32 seconds. So not quite 4 times faster, but definitely noticeably faster. So all right, now let's take a look and see how does it perform when I use all 8 GPUs. And in this case, that means we're going to use the GPUs from this local machine as well as the GPUs from the remote machine as well. So again, we're going to restrict the search range to just 3 arc seconds per minute just for this example. And we're going to allocate all of these remote nodes. And so now we have 8 in total. Even though it says remote, that's just because it's not the instance that I'm using here. Anyway, so yeah, it's going to distribute, and we're going to run the process. And so let's see how long this takes. Okay, so that was pretty fast, and it took 20 seconds. So, if it was previously 32 seconds, and we have twice as many, you would expect 16. There's a little bit of overhead with the loading up the files and that sort of thing. So honestly, a more accurate benchmark would be to have a data set that's even more involved. But I think this example is fairly sufficient to show that the cluster computing works quite well. And so this is 1.3 E14 vector pixels per hour using all these 8 GPUs for this particular detection threshold and so forth. And the results, again, are the same. It detected the genuine asteroid and then all these synthetic ones, and again 907 total tracks. So same results and much faster to process. Now, if you recall, it was previously 20 seconds for all 8 GPUs and 32 seconds to operate on 4. Again, those were Tesla K80 GPUs. So I actually have on this machine an RTX 2080. So I'm going to run it on this local machine here, just one GPU. Okay, so the idea here is to compare the performance of a NVIDIA Tesla K80 GPU versus an NVIDIA RTX 2080. So like K80 is fairly old technology. I think it goes back to like 2012 perhaps. Anyway, versus the RTX line is far more recent. Even though it's a consumer grade card, it's much better, and you can see that here. So if we look at the number of seconds, okay, so 36 seconds, and I'm using all the same detection threshold settings and everything. So that's very good because that's just one GPU with this RTX 2080, as you can see in the device selector. So yeah, I think that's a good way to compare and contrast. Of course, this machine has a different CPU, and so there are some other variables as well, but the main thing is that's quite a nice improvement for just one GPU. So anyhow, hope you liked the benchmark comparison. So thanks for watching.